Today we're going to go a little bit deeper into the quadratic formula and specifically one portion of it that can definitely influence the answers that we get out when we're trying to solve quadratics. So if we look at our quadratic formula, we have x equals negative b plus or minus b squared minus 4ac, or square root of those, under 2a. But specifically, if we look at that value, the b squared minus 4ac, knowing what that value is and what would happen when we take the square root of that, that can actually let us predict what kind of solutions we're going to have. So we actually have a name for that. That is called the discriminant. And that's just what we would calculate under that square root from our quadratic formula. And there are technically four scenarios that we have to take into account. So if under that square root, we ended up with a negative number, well, let's think of that. If we take a negative value, actually, let me shrink this down a bit. If we have a negative value that we're taking a square root of, well, that's when we have an imaginary number come out. And that makes our answer for the quadratic formula actually a complex value. So when we have negative as the discriminant, that means we'll have two solutions that are both complex or imaginary values. And if we're actually going to get a solution for that equation, we have to use quadratic formula to do that. There's no other way for us that we know of right now to get those complex answers out. Our second scenario is, well, what if that value is equal to 0? So keep in mind, let's see, well, previously we had square root of negative numbers like square root of negative 1. Well, what's the square root of 0? Well, it's just 0. And when we're looking at our function, well, we'll have like some number, let's say like a 3 plus or minus a 0 over, 2a, let's just say 2. But when you add 0 or subtract 0, it doesn't really do anything to your value at all. It doesn't change it. So really, when you have a 0 as your discriminant, that means you're only going to get one solution. And so these are the scenarios where, if you see the graph below it, where we only have that one x-intercept where our parabola pretty much hits the x-axis and bounces right back up. And when that scenario happens, we could actually use just about any method. This is probably going to be something that you could solve that by factoring. You could solve it by graphing and looking for that x-intercept. You could use completing the square and still get a solution, but you could also even just go through do completing the square, or even just isolate your x squared, because usually these values, they potentially are just moving left or right, not moving up or down, and that definitely simplifies the quadratic equation that we're working with. And then our third scenario is when we have a positive value. So we kind of divide this up into two sections. So one is if we have a positive, but it's a perfect square. So if we had like square root of a 4 or 16, something that simplifies out very nicely. Well, that means our answer is just going to be a fraction that we can simplify. We're going to get a rational solution. Again, rational number being anything you can write as a decimal or a fraction. But if we have something that's not a perfect square, let's say like square root of 7, well, then we're going to get an irrational number. Again, when you take the square root of something like 7, you don't get out a nice answer. You get a decimal that never repeats, it never terminates. And again, those are called our irrational numbers. And for the scenario with a perfect square, again, we could probably use any method to solve that out. It might even be factorable. When we have an irrational, again, we're kind of stuck with using either completing the square or quadratic formula. So let's look at a few equations and use the discriminant to kind of predict what these are going to look like. So here we go. So first set of examples, find the discriminant and describe the roots for each quadratic. So again, your discriminant is just going to be what's under the radical, aka b squared minus 4ac. So first thing is we need to actually make sure that we know those values. And actually our first one, that is not supposed to be an equals, that's supposed to be a plus. So please go ahead and change that on your copy. I'll go ahead and update the blank copy version that you have as well. And so our A value is our 9, B value is 12, C value is 4. So let's plug them in. So our discriminant is going to equal in b squared minus 4 times our A times our C. So let's see, actually, let me bump that up a little bit in size. So 12 squared gives me a 144 minus 4 times 9 times 4 aka 36 times 4, which comes out to 144 again. So actually, in this case, our discriminant is equal to 0. So that means we're going to have one rational root. Again, because if we add and subtract 0, it's not going to change any value in that numerator if we continued with our quadratic formula. Alrighty, let's look at number 2. And actually, let me go ahead and move these over, get my work centered a little better. There we go. Okay, number 2. 2x squared plus 16x plus 33. Again, everything's already set up, ready to go for us. So here we go. Our discriminant equals b squared, in this case is 16, minus 4 times our a, which is 2, and our c, which is 33. And this is one definitely, you might have 16 squared. If I'm not having the greatest day, I always like to check my math. And then we have 4 times 2 times 33, which comes out to 264. And this is absolutely going to get us a negative value. Specifically, 256 minus 264 gives us a negative 8. So that negative 8 is underneath the radical, which means what happens when we take the square root of a negative number? That's when we get our imaginary value, which will give us complex answers. So we will have 2 complex solutions, or roots, or answers, or technically x-intercepts, however you want to express it. They are almost interchangeable words. Alrighty, go ahead and let's see, number 3 and number 4. Number 4, we should have that as equals 4. Again, I will update that on the blank copy, so you'll have that already available. Go ahead and pause the video and try finding your discriminant on these. Now, keep in mind, with these, the first thing you want to do is make sure that your expression is equal to 0, just like if you were doing quadratic formula. So make sure everything in your equation is set equal to 0. Find your discriminant and see what happens. Okay, let's see how you did. So again, our A, B, and C values. This, we would have to subtract a 1 from both sides. So really, it's going to be a -1 equals 0, ultimately. So our C value will be that -1. Okay, so our discriminant, B squared minus 4 times our A times our C. Now, this is one of those we want to be very careful with these negative signs. So 8 squared is just a 64. We're going to do a -4 times -5, times a -1. Well, negative times negative gives us a positive, but times another negative gets us back to a negative again. So we're subtracting 20. Except that actually comes out as a positive number. However, it comes out to 44. 64 minus 20, just to double check, 44. That's not a nice, perfect square number. So if that was under the radical, again, we're looking at an irrational number, which means we're going to have 2 irrational roots. Okay. So number 4, again, it should have been an equals 4, not a -4. But I need to do some rearranging on this one. I'm going to go ahead and rewrite it as x squared, x constant. So that means I'm going to move the 15x squared out front. I'm keeping the 7x on the same side, so I don't need to worry about changing my signs on it. But the 4 I need to subtract from both sides. Alrighty, now let's look for our discriminant. So b squared minus 4 times a times c. And -7 squared, any negative value squared is always going to give us a positive. We have a -4 times 15 times a -4, which means it comes back out to a positive. So positive 240. So this whole mess comes out to a 289. Is that triggering any memory of yours? Now check to see if it's a perfect square or not. So let's try it. So plug in your calculator or Desmos, square root of 289. Hey, that's actually a 17. We have a perfect square number on this one, so that means when we simplify out our quadratic formula, no more square roots of odd numbers. So that means everything's going to simplify out to rational values. So we're going to have 2 rational roots. Okay, that's really the only new piece of this. So when you look at a discriminant, again, it'll let you predict what values you're going to get out when you finish up solving with quadratic formula. But your quadratic formula, it's still the same technique that you used in our previous lesson. So just as a reminder, kind of comparing all the methods that we have. So let me scroll down a bit and shrink this down. So we pretty much have 5 methods that we could use. So we can graph everything out. So if you graph a parabola or a quadratic equation, then you're looking for your x-intercepts. Now that's only going to work when you have rational or irrational values. It will not work if you have complex numbers because they will not show up on our regular XY coordinate graph. You could solve some things by factoring, but again, it's only if the expression factors out nicely. Let's see here. We have our square root property again, which is pretty much if you take the square root of both sides, solving out for x. But the biggest thing is only use that when you can isolate the x or the x plus or minus whatever value, because then you can take the square root of both sides. Again, you're sometimes going to get irrational values, but it's similar to what we did when we were solving by completing the square. And specifically, you could actually use completing the square method to solve things out. So this square root property is pretty much one of those steps from completing the square. And again, you could use that on every possible equation, whether it factors nicely or not, and you'll still get a solution. And it's the same thing with quadratic formula. You can apply that to every single problem and it will get you a solution. And it doesn't matter if it's rational roots, irrational roots, or complex roots, you'll still get answers out of that equation. So your practice today is actually going to be using this discriminant piece, but it's also going to have some review pieces in there as well. So please do check that out. Your lesson check is actually over the last couple lessons. So again, it'll have a combination of material in there for you to practice. As always, let me know if you have any questions, especially if first try on your lesson check doesn't work so hot. Check out your results. And if you don't understand how to fix the problem, pop back into Zoom or shoot me a message and we can check out that problem. If not, I'll see you later.